Hello everyone! Welcome sa aking second tutorial videos in organic chemistry, and this time I will talk about Lewis structure. Okay, so bakit importante ang Lewis structure? This is because it is a fundamental way to understand the reaction of organic compounds and also the mechanism, kasi kung hindi mo alam kung paano mag-draw ng Lewis structure, then you can account for electron pushings and mechanisms, and you cannot account for the bonding patterns and reactivity patterns of organic compounds. Okay, so Lewis structure, it contains the following. First is that it must have a proper number of electrons. So dapat tama yung total valence electrons ng isang compound with respect to the atoms present based on the molecular formula. And number two is that dapat may correct distribution ng mga electrons na yon around the atom. It could be a bond or it could be a lone pair. Okay? And number three is it has correct formal charge. Now in this video I will not talk about the formal charge, but I will have a separate video of it talking about it instead. But before we proceed to the steps on how to draw the Lewis structure, it is very important to know these two rules, the duet and octet rule. Okay, so I have here a snapshot or a screenshot of a portion sa periodic table, okay, with minus the transition metals, okay, because organic chemistry only involves sp orbitals. So makikita nyo itong atoms represented as Lewis dot symbol. Okay, sa Lewis dot symbol, the dots around the atom, okay, around the atom is what we call a valence electron. Now, ang valence electron, ito yung mga electrons na nakikita mo sa outermost shell ng isang atom, or ito yung mga electrons na nakikita sa highest energy level ng isang atom. So the quickest way to determine the valence electron of an atom is by looking at its group number. Okay, this is the group number. Okay, 1A, 2A up to 8A is what we call the group number. Okay, so for example, carbon. Okay, si carbon under siya sa 4A na group number. So therefore, ang valence electron niya ay 4. That is why it has 4 dots as represented by this Lewis dot symbol. And nitrogen, meron siyang 5 valence electrons. That is why ito yung kanyang Lewis dot symbol. And sa duet rule, this is the kind of rule applicable solely for hydrogen, because si hydrogen, kailangan niya lang ng dalawang electron. Okay, one electron from him and another electron from another atom, and they share it together, and hydrogen can have 2 electrons, okay, shared between another atom. Okay, so that is why hydrogen can only have up to 2 electrons maximum for it to achieve stability. Okay, so the other one naman is octet rule. Si octet rule, ito yung electrons na kailangan ng mga atoms like carbon, nitrogen, oxygen, and halogens like fluorine and chlorine in order to achieve stability. They need a total of 8 electrons, okay, in order to achieve stability. So saan nila kukunin yun? The way they do that is that they will bond to another atom covalently para ma-attain nila yung octet rule. Okay, so that is why fluorine needs 1 electron from a nearby atom, and also chlorine, and also bromine and iodine. Okay, si oxygen, kailangan niya ng 2 electron sa another atom to complete its octet. Si nitrogen, kailangan niya ng 3 electrons from another atom to complete its octet. And si carbon, kailangan niya ng 4 na electron from another atom to complete its octet. That is why carbon is what is called tetravalent, okay, or the covalency of carbon is 4, meaning tetravalent. Okay. So kailangan ni carbon ng 4 na electrons from another atom. That is why it can make up to 4 bonds, okay, regardless of whether or not it is a single bond, double bond, or triple bond. Okay, si nitrogen kailangan niya ng tatlo, that is why it can have 3 bonds. Si oxygen, it could have kailangan niya ng dalawa, that is why kailangan it can have single bond, but in some cases it could also have 2 bonds. Okay, halogens naman, they can have single bonds. Okay, now I have here the procedures for drawing Lewis structures, but before that, let me share to you a table of the bonding patterns and electron pair domains of the common elements or atoms in organic chemistry. Okay, so an electron pair domain, ito yung mga region sa isang atom na merong electron density. Okay, so in this bonding pattern of hydrogen, it has one electron pair domain. Okay, by the way, electron pair domain, they could be lone pair, they could also be bonds. Okay, so si carbon naman, carbon can be represented by these 4 Lewis structures, and with this Lewis structure, it can have 2 electron pair domains, one here, and this, okay, and so on and so forth. So si nitrogen naman, ito, and this Lewis structure, it has 4 electron pair domains, 1, 2, 3, and 4 from the lone pair. So here are the steps in drawing the Lewis structures. Number 1, you need to find the valence electrons, and pangalawa, you need to draw a preliminary structure na symmetrical and draw single bonds between the atoms. Okay, and number 3 is that you need to obtain or determine the shared electrons. Ang shared electrons, ito yung mga bonds, okay, single bonds from based on the preliminary structure na drawing natin. And take note that one bond or one single bond is equivalent to 2 electrons. Number 4 is you need to count the number of unshared electrons, and you can achieve this, or you can get this by this formula. Using this formula, valence electrons in number 1 minus the shared electrons in step 3. Okay. And number 5, these unshared electrons, you need to distribute it around those atoms na incomplete ang octet. Okay. So I have here an example. Draw a Lewis structure of ethylene with a molecular formula of C2H4. So step 1, we need to determine the valence electrons first of all the atoms in the structure of ethylene, and you need to base it on the molecular formula. So in this case, we have carbon, we have hydrogen, valence electron, and number of atoms. So we have here the total VE. Okay, the valence electron of carbon, don't forget on the table, on the periodic table, it belongs to group number 4A. So it has a valence electron of 4, and hydrogen is 1. Ang number of atoms ni carbon sa molecular formula is 2, so it has 2. Hydrogen is 4, making this 8 electrons, this one 4 electrons, and you need to sum this up to get the total valence electrons. Okay. So step 2, we need to draw a preliminary structure. Na symmetrical, of course. So this is the most symmetrical structure that we can draw for ethylene. So you need to draw a single bond around it. Okay, so step 3 is determine the shared electrons, and shared electrons are those can be found as single bonds. So remember that single bonds is equivalent to 2 electrons. So 2, 4, 6, 8, 10. There are 10 electrons, shared electrons. And step 4 is the unshared electrons, which can be obtained using this formula, minus shared electrons. Okay, so in this case, 12 electrons from step 1 minus the shared electrons in step 3, we have 2 electrons. Now, itong step 4, makukuha natin yung unshared electrons, diba? So, in this case, 2 electrons. So, we need to distribute these 2 electrons around the preliminary structure. Okay? So, sa step 5, I have here common mistakes na ginagawa ng mga students, okay, sa pagdraw ng Lewis structure. They might do it like this. They might distribute these 2 electrons sa carbon because, you know, based on the preliminary structure, si hydrogen, it has complete duet, but si carbon 1 and 2, it has incomplete octet because carbon 1 has 2, 4, 6, and carbon 2 also has 6 electrons only. So we need 2 more each. Okay? And common mistake ng mga students, if I will have to draw these 2 electrons as violet, okay, if I were to draw it as violet, they will have it like this. Okay, is this a proper way of drawing the Lewis structure? No, because carbon 1 will have 7 electrons, 2, 4, 6, 7. Okay, so carbon 2 as well, 7 electrons, 2, 4, 6, 7. It still has no complete octet. Okay, another mistake. Okay, a common mistake is that students will distribute these 2 electrons like this. Okay, so carbon 1 has complete octet, of course, 2, 4, 6, 8. But carbon number 2 only has 6 electrons. Remember that the correct Lewis structure always has those atoms with complete octet. Dapat, kung mag-draw kayo ng Lewis structure, take note na dapat kompleto yung octet ng lahat ng atoms na makikita nyo sa structure. So, this is an incorrect way of drawing the Lewis structure. Okay, if I want to draw it again, okay, so these 2 electrons, instead of distributing it as a lone pair, you can have it as a bond. Okay. Okay, so carbon 1 has 8 electrons, complete octet, 2, 4, 6, 8, and carbon number 2 has complete octet, 2, 4, 6, 8. So this, my friends, is the correct structure of ethylene. So we have here another example. It says draw a Lewis structure of ethyl chloride with the molecular formula of C2H5Cl. Okay, so first we need to determine the valence electron. Step 1. Step 1, valence electron. So we have carbon, hydrogen, and chlorine. We have valence electron here, number of atoms here, and we have total valence electrons here. So carbon has 4, hydrogen has 1, chlorine has 7. Since halogens belong to 7A, group number 7A, and there are 2 carbons, there are 5 hydrogens, and 1 chlorine atom. So this is 8, this is 5, this is 7. Multiply all this, and you need to sum this up to get 20 electrons. Okay. So step 2 is that you need to draw a preliminary structure that is highly symmetrical. You need to think of the most symmetrical pattern, okay, in your mind. So in this case, this case, the most symmetrical description, it looks like this. Okay, so you need to Why symmetrical? Because it has plane of symmetry around this axis. Okay. Oops, sorry. So you need to draw single bonds. You need to draw single bonds each. Okay. So step 3 is identify the shared electrons. In this case, 2, 4, 6, 8, 10, 12, 14 electrons. Step 4, unshared electrons. We have valence electrons minus shared electrons. There are 20 valence electrons minus 14 electrons. You get 6 electrons. Okay, we'll have to draw it in violet. 6 electrons. Okay, so step 5, you need to draw the Lewis structure by distributing these 6 electrons. Okay, I will have to draw the structure again, the preliminary structure I mean. Okay, so I have to label this as 1 and 2. So carbon 1 is complete, of course, all hydrogens has complete duet, and carbon 1 has complete octet, 2, 4, 6, 8, as well as carbon 2, 2, 4, 6, 8. But chlorine only has 2 electrons. Okay, so it needs 6 electrons more, and we can get it from this 6 electrons in violet in step 4. Okay, so we need to distribute this as lone pairs, not bonds, because you have no atom based, you have no any other atom based on the molecular formula, so it doesn't make sense to distribute this 6 electrons as a bond. Okay, so just erase this one. So we have to distribute this as lone pairs. So 1, 2, 3, 4, 5, 6. So there you have it. We have already drawn the Lewis structure of ethyl chloride. And another example is draw a Lewis structure of methanol with a molecular formula. No, this is not the molecular formula, but the chemical formula, I mean CH3OH. Okay, so sorry about that. So step 1, find the valence electron. We have carbon, hydrogen, and oxygen. So the valence electron here, number of atoms here, and total valence electron. We have 4 for carbon, 1 electron for hydrogen, and 6 valence electrons for oxygen. So there are 1 carbon atoms in the chemical formula. There are 4 hydrogen atoms in the chemical formula and 1 oxygen. So the total, you just have to multiply this 4, 4, and 6, giving you a total of 14 electrons. Okay, so step 2, you need to draw the preliminary structure that is symmetrical. The preliminary structure would look like this. Okay. Okay, this is the most symmetrical way because you have a plane of symmetry around this axis. Okay, so we need to draw single bonds. Okay, so step 3 is the shared electrons. How many? 1, 2, 3, 4, 5 times 2, 10 electrons. So step 4, we need to compute for the unshared electrons. Valence electron minus shared electrons, that is 14 electrons here, and shared electrons of 10, giving you 4 electrons that are unshared. Okay, So just change color for electrons. Okay, so step 5, allow me to draw this preliminary structure again. Okay, so this 4 electrons should be distributed to the atom with an incomplete octet. So hydrogens have complete duet, carbon has complete octet 2 4 6 8, but oxygen only has 4. Okay, oxygen only has 4 electrons. Okay, this and this, so it needs 4 electrons more. And how are we going to do that? Well, it could be either a bond or a lone pair. Okay, so for example, we could draw it like a bond. Okay, this is 2 electrons and this is 2 electrons. This is actually incorrect. Why? Because while you satisfy the octet of oxygen, you are dissatisfying the duet rule of this hydrogen, and you are dissatisfying you are deviating from the octet of carbon, because carbon now has 10 electrons, 2 4 6 8 10. So distributing these 4 electrons as a bond is not possible. Instead you can distribute these 4 electrons as lone pair, 1 2 3 and 4. So this is the Lewis structure of methanol.